We're going to look at one more example. It says, let B be the basis 1, 1 plus x, 1 plus x plus x squared for P3, which is the polynomials of degree 2 or less. And we want to define an inner product on this space, P3, by the following. If we have P and Q, there are two polynomials in P3. The inner product is the sum of P of xi times Q of xi, where I runs from 1 to 3, and x1 is -1, x2 is 0, and x3 is 1. We want to find an orthonormal basis for P3. Okay, so let's recall what we need to do to find an orthonormal basis. And I will come back up to this problem in just a second. So I just want to write out the formulas. Remember that an orthonormal basis which I'm calling B hat, is a set of vectors u1, u2 to un, but in this case, this is a three-dimensional space. We have three vectors here that we can label v1, v2, and v3. So we're going to need three orthonormal vectors. And how we find u1 is we take the very first vector and multiply by 1 over its length. And then for I is 2 or 3, maybe I don't want to use the letter I, we'll say k. UK for k is 2 or 3, this is equal to z k minus 1 over the length of z k minus 1, where zk minus 1 is equal to vk, subtract the sum, from I is equal to 1 to k minus 1 of vk with ui, the inner product of these two, that's a scalar, multiplied by the vector ui. So this is the formal definitions of how to find this orthonormal basis. So for u1, u2, and u3, we're going to use these formulas. Okay, let's start with the first one. So you might want to copy this down, and I'm going to erase it so we can see the problem. So for the first one, we just take v1 and divide by its length. Okay, so v1 is equal to the vector 1, and the length of v1 is the square root of the inner product of v1 with itself. Well, let's find the inner product of v1 with itself. Now look, here we're going to put v1 and v1, so we need to plug in the values of these xi's into the polynomial 1. And each time when we plug it in, we're going to get the polynomial 1, right? So if p of x is equal to 1, then p of -1 is equal to 1, p of 0 is equal to 1, and p of 1 is equal to 1, because it's just the constant polynomial 1. Okay? So the inner product of v1 with itself is the sum from I is 1 to 3 of 1 times 1. because I'm going to plug in -1 into 1 and -1 into 1 because this is the same polynomial, and I'm going to get 1 times 1. Then when I plug in 0, I'm going to get 1 times 1, and if I plug in 1, I get 1 times 1. So this is equal to 1 plus 1 plus 1, which is 3. You see we have this sum going from 1 to 3. So the length of V1 is the square root of 3, which tells us that U1 is 1 over the square root of 3 times the vector 1. So you can leave it like this, or you can write it as 1 over the square root of 3. I prefer this notation, but either one is fine. And if this was like a vector, a column vector, something like this, and you had the square root of 3, you could send it into everything. So 1 over the square root of 3, 2 over the square root of 3, 3 over the square root of 3, so on. Okay, so we have our first vector. Let's circle it, and actually let's put it in red. Okay, now we need to figure out what U2 and U3 are. So U2 is 1 over the length of Z1 times the vector Z1, where Z1 is equal to V2 subtract the inner product of V2 with U1 times U1. Let's figure out what this inner product is. So the inner product of V2 with U1 is the inner product of, well, let's recall what V2 is. V2 is this polynomial 1 plus x. So it's the inner product of 1 plus x with 1 over the square root of 3 times 1. We have a scalar here, and remember we can pull the scalar outside of the inner product. Okay, and now we want to take the inner product of these two, which means we need to figure out if p of x is equal to this polynomial 1 plus x. So this is our p here, and this is our q. We need to plug in those three values into p. So our values were x1 is -1, x2 is 0, and x3 is 1. Let's plug in those three values into this polynomial. So p of -1 is 1 minus 1, which is 0. P of 0 is 1 plus 0, which is 1. And p of 1 is 1 plus 1, which is 2. And remember, if we plug in these values into the polynomial 1, we just get 1. So that tells us that the inner product of 1 plus x with 1 is the sum of these three values. We have 0 times 1 plus 1 times 1 plus 2 times 1. So let's just review what the inner product was. I'm going to move up just a little bit. Remember, you plug each one into p. So we're plugging in -1, 0, and 1. And this is going to remain 1 each time. And then we just add those three numbers together. So what do we get? So this is a 2 here. We get 1 plus 2, which is 3. So the inner product is 3. But we took out a scalar. Now we did this without this scalar here. We only found this part. So we need to multiply by 1 over root 3 when we plug that into this formula here. So what I'm going to do so I can kind of, not have to move way far down, I'm going to erase this. And I'm going to put 3 here because that's what the inner product is. So 3. And now we can put 3 over root 3 here. So z1 is equal to v2 minus 3 over root 3 times u1. And u1 is 1 over root 3 times 1. And what happens now, as you can see, is we have double of this radical. So if you multiply root 3 with root 3, you get 3. And then 3 over 3 cancels. And don't forget that we also have, we have this 1 here, so we're good. So we end up with z1 is v2 minus 1, because all of this stuff cancels. And v2 is 1 plus x, so we're subtracting 1, and I get just x. Okay, so that's z1. And then to find u2, we need to take x and multiply by 1 over the length of x. All right, let's figure out the length. The length of x is the square root of the inner product of x with itself. We need to plug in those 3 values into x. Remember that our 3 values are x1 is -1, x2 is 0, and x3 is 1. And if we plug them in x, we just get exactly what we see here. So the inner product of x with itself is -1 squared plus 0 squared plus 1 squared. So we end up with 2. And the length, the length of x is root 2, because we have to take the square root of this. So now we have figured out what u2 is. u2 is 1 over the square root of 2 times x. Great. Now let's move this up to where the other vector is. And then we're going to figure out what u3 is equal to. All right, so I'm going to erase this piece and this piece. And let's write out what u3 is. So u3, which is the final vector that we need to find. Remember, we needed 3 vectors, u1, u2, and u3. So u3 is 1 over the length of z2 times z2, where z2 is v3 minus the inner product of v3 with u1 times u1, subtract the inner product of v3 with u2 times u2. So we need to figure out these 2 inner products, this one here and this one here. Let's start, I guess, with this one. I don't like how I wrote that u. I'm going to rewrite it. Okay. So what is the inner product of v3 with u1? Now you might want to recall what v3 was. It is 1 plus x squared. And u1, well, it's right here. It's 1 over the square root of 3. I'm going to take this outside and just be left with 1 in here. So this is 1 over root 3, 1 plus x squared, 1. And then we're going to plug in those 3 numbers. So this is 1 plus x squared, 1 is equal to. So remember, if we plug in the 3 numbers, we get 1 for this polynomial here. But if we plug in, let's say p of x is 1 plus x squared. If we plug in -1, we get 1 minus 1 plus 1. -1 squared is 1, so we just get 1. If we plug in 0, we get 1 plus 0 squared, which is 1. And if we plug in 1, we get 1 plus 1 squared, which is 1. So here, 1 plus 1 is 3. Okay, so that tells us that the inner product is 1 times 1 plus this one, 1 times 1 plus 3 times 1. For the 1 here, that corresponds to this 1. And then from there, we get 1 plus 1 plus 3, which is 5. Okay, so this thing right here, which I've written here, is 5. So we can erase this and put 5. And so the inner product right here is 1 over 3, root 3 times 5. So I'm going to erase that and plug it in right there. So 5 over root 3. Okay, now let's take care of this last one. So I'm just going to adjust this stuff. Okay. All right, so I need to figure out the inner product of V3 with U2. So I need V3 with U2. V3 is 1 plus x squared. U2 is x over root 2. And remember, I can take out these scalars, so I get 1 over root 2, 1 plus x squared with x. All right, we just did this, we plugged in all the values, -1, 0, and 1 here earlier, but I erased it, so I'm going to have to do it again. And since this is x, it's just equal to the values. So again, if we have p of x is 1 plus x squared, we said that p of -1 was 1, p of 0 was 1, and then p of 1 was 3. And then if q of x is x, if we plug in -1, we get sometimes my thing just drags for some reason. Anyway, if we plug in -1, we get -1. If we plug in 0, we get 0. And if we plug in 1, we get 1. So now we can take this inner product. This inner product, 1 plus x squared with x, is equal to plug in -1 into both of these, so we get 1 times a -1. Add to it, plug in 0 into both, we get 1 times 0. And if we plug in 1 into both, we get 3 times 1. So we get -1 plus 0 plus 3, we get 2. And then we have this, so this part is completed and it's being multiplied by 1 over root 2, so we get 2 over root 2, and that's what we can plug in right here. So let's do that. So this is 2 over root 2. Great. Okay, so we're almost done. Let's just get rid of all this stuff. Okay, and now that we have this formula for Z2, we're just actually going to calculate it. So I'm going to put in what V3 is. I'm going to put that right here, and then I'm going to put what U1 is and what U2 is in these positions. So Z2 is V3, which we said is 1 plus x squared, minus 5 over root 3 times U1. Well, if you recall, U1 is 1 over root 3, minus 2 over root 2 times whatever U2 is, which is x over root 2. So we're left with 1 plus x squared minus 5 over 3 minus x, because this is a root 2 times root 2 is 2, and those 2 and the 2 cancel. Okay, so from there we can see that the x's cancel, and this is 3 over 3, so we could write this instead as 3 over 3. This is the same thing as 1. So we're left with x squared minus 2 over 3. And now that is Z2, and to figure out what U3 is, remember we divide by the length of Z2. So that's what I'm going to do. I need to find the length, so I need to take the inner product of x squared minus 2/3 with itself. Okay, and then we need to take the square root, and that will give us the length. So let's write that. The square root is the length of Z2. We need to plug in those 3 numbers. So the 3 numbers were x1 is -1, x2 is 0, and x3 is 1. You can see that if I plug in, the polynomial is x squared minus 2/3. Plug in -1, I get p of -1 is 1 minus 2/3, which is just 1/3. If I plug in 0, I'm left with -2/3, because 0 minus 2/3. And then if I plug in 1, I get the same thing I get here, because it's 1 squared, which is 1 minus 2/3. I get 1/3. Okay? And the inner product of x squared minus 2/3 with x squared minus 2/3 is, well, we just multiply, because we have the same polynomial here. We take 1/3 and square it. So we plug in the first number first in, plug in the first number, which is -1. And then we square the second one, which is -2/3. Then we square the last one. So we get 1 over 9 plus 4 over 9 plus 1 over 9, which is 6 over 9, which is 2/3. Okay? So then the length of this vector Z2 is the square root of 2 over 3, which if you want, you can write as root 2 over root 3, which is root 6 over 3. If you multiply the top and the bottom by root 3, that's what you get. Okay, so now we can write what the last vector is. U3 is equal to root 6 over 3 times x squared minus 2 over 3. So that is our last vector. And let's group all of these guys together. Let's move him up. Let me get rid of some of this again. Okay. Okay, I'm close enough. Here we go. Here are our 3 vectors, U1, U2, and U3. So how do we know we didn't make a mistake, which is very possible that we made a mistake. Well, obviously the first one shouldn't be a mistake. That was easy to figure out. Remember that we want these to be orthonormal, so that ui with uj is equal to delta ij, which means is equal to 1 if I have the same vector, and is equal to 0 if they're orthogonal. So you want to make sure that happens. So you could actually take the inner product of these two, u1 and u2, make sure you get 0. Take the inner product of u1 with u3 and get 0, and take the inner product of u2 with u3 and get 0, and then just find the length of all of these and make sure they're equal to 1. That's if you got a lot of extra free time, but hopefully you didn't make any mistakes. Yeah, so this is the answer, and we have finished our last problem involving the Gram-Schmidt orthogonalization process.